All right, let's get going here. Hello, AIA Chicago. This is David Swain. I'm the co-chair, along with Dan Giaconetti and Kelly Moynihan of AIA Chicago's Committee on the Environment. Welcoming today Don Thompson from NRMCA and Ryan Cialdella from Ozinga to speak to low embodied carbon in concrete and cement and innovations that are being made. Before getting going, though, I'd like to thank NRMCA for their sponsorship of a Committee on the Environment events, along with Rockwool. And I'd also like to just also thank sorry about that, um, our 1869 Circle partners that you see on the screen that are sponsoring many events for AIA Chicago this year. So special shout out to all of them. And with that said, really like to thank Don and Ryan for joining us today. And I'll give it to you, Don, to start off this conversation. So thanks so much for being here today. And you can share your screen when you get a chance.
Sure. Thank you, David. And thanks to all of you for joining us today as we talk about concrete innovations and pathways for reducing carbon footprint. Our industry, as you'll see, has been very proactive for probably the last 15 plus years in looking at these issues effectively, because concrete is so unique from the standpoint of how customizable it is. When you work with ready-mix concrete, every application is basically created for the specific requirements that are needed for a given project or application. And that's very different from many building materials that are more of a one-size-fits-all approach. And so because of the customizability of ready-mix concrete, there are unique challenges that our industry needs to address when looking at documenting the sustainability of the multitude of mixes that can be created using the various combinations available to our industry. So with that, I'd like to turn it over to Ryan Cialdella, Vice President of Innovation and Market Development at Ozinga, who will do the first half of our presentation, and then I will come on to talk about industry-wide efforts that we're making in regards to reducing carbon footprint of ready-mix concrete. So with that, Ryan, I'll turn things over.
Okay, thanks, Don, and thanks AIA Chicago for the opportunity to share some of the things we've been working on. For those who don't know, Ozinga is a fifth-generation family-owned ready-mix company in our 96th year. And, we've taken this initiative pretty seriously the last 3 to 4 years as we started to see the market demand shift towards lower carbon materials. And, excited to kind of talk about some of those things. If you could jump slides, Don. So today, just covering our learning objectives, and we'll get into the weeds on some of these. But, ultimately, we're going to talk about reduction of Portland cement, the largest contributor in our final product of concrete to the overall global warming potential, some of the different technologies that we've employed in terms of reducing that carbon footprint. And then, again, looking at all aspects of an EPD, right? And we'll understand the different categories. And as part of that, talking about the different fuels that can be used as well in trying to drive that carbon footprint down, because it's going to take a lot of different products, technologies to kind of really just keep chipping away at the carbon footprint. And we really feel like, stacking a lot of these different new materials, technologies, the alternative fuels all together is really what's going to help us ultimately get to zero. If you could jump slides. So as I'm sure you all know, for a long time, a lot of focus and effort was put on operational carbon, LED lights, high efficiency, HVAC, things of that nature. But this is really focused in honing in on the embodied carbon, right? Starting from the minute you put the shovel in the ground on a project, what are the materials that we're using and what is their impact on the overall structure? And then, again, ultimately the goal is how do we drop that number down as we continue to build new facilities, buildings, infrastructure, all across the board with concrete. So next slide. Next slide, sorry. So again, building sustainably, right? Again, as I mentioned, cement is the production of Portland limestone cement or regular Portland cement is the biggest contributor in our final product. So ultimately, the low-hanging fruit is how do we replace as much cement as we possibly can while still maintaining the performance and the hardened properties that we have all grown to love about concrete. So, traditionally, using supplementary cementitious materials to replace Portland, whether it's fly ash, slag, natural pozzolans, ground glass. I mean, there's a lot more coming out into the woodwork now as, fly ash continues to go away as they're shutting down coal-fired power plants. So, understanding what are the limitations of some of these products and how do we maximize the replacement? Because as I said, cutting out the Portland is the fastest way to drop it, but as you know, we still need to have some Portland in there to make, concrete get hard. So, and then on top of that, as I mentioned, looking at various technologies, what else can we bolt on top of what we're already doing to chip away at that global warming potential and understanding how are they implemented, not only from an operational standpoint, but where do they fit in terms of specifications and approvals? And, really what is the potential that they have to help us continue to reduce the carbon footprint. One of the ones that we started working with back in 2016, 17 was Carbon Cure. And, surprisingly, I was very happy with, what we were told and what they presented to us in terms of the ease of implementation and really not having any effects on any of the hardened properties or plastic properties of the concrete. Next slide, please. And so ultimately what Carbon Cure does is we take CO2, we inject it into the concrete as we are loading the truck, and you basically get a reverse calcination. And so, going back to the starting point for cement, when they fire limestone, you're breaking off the CO2, which is one of the big emitters of the product, and then also all the fuels that take to get the kiln up to that temperature. So that's why it has such a large carbon footprint. But what we're doing when we're putting the CO2 back into the concrete is we're a reverse calcination. So that CO2 is finding the free lime, the CaO, and it's combining back into limestone. But the advantage is it's forming it at a nanoscale. Jump to the next slide. And those nano limestone particles bind to the cement grains and ultimately enhances the effectiveness of each one of those cement grains. So ultimately, you're getting a higher compressor strength by doing this, therefore allowing us to back down the amount of cement that needs to be used to achieve the same performance. And, that reduction in cement can be anywhere from 5 to 7%, depending on the mix and the materials that you have. So again, it's just another layer on top of fly ash and slag. Using this technology has no bearing, no effect on any of that. It doesn't limit the use of those at all. So it's just kind of stacking these on top of each other. And, just a quick shot here, basically as the CO2 hits atmospheric pressure, it basically turns into dry ice. So you're, ultimately kind of putting ice into the concrete. And, a common question is, does it make it colder or reduce the temperature? No, it's only about 1.5 pounds of CO2 that goes into each yard of concrete. So not enough to affect any of those properties. And again, there's also been concerns about does it change the pH or affect the corrosion? And there's been very long, extensive studies that have been done that it does not accelerate the corrosion of any structural reinforcement. So again, no, negative attributes, doesn't change the finishability, doesn't change the pumpability. It just really enhances the concrete strength, allowing us to pull cement out. Next slide, please. So just a couple examples here locally, when they redid the McDonald's down, right in the heart of the city here, we offered the opportunity to use Carbon Cure in this project and ultimately reducing the amount of cement needed. So we saved about 30,000 pounds of CO2 and, delivered a yard of concrete that was quite lower than the benchmark, roughly 55%. So again, very seamless. Contractors, again, wouldn't even know it was in there if we didn't tell them. Next slide. As I mentioned, 30,000 pounds on this particular project, which is equivalent to a 16-acre forest sequestering CO2 for a year. So, imagining 30,000 pounds of CO2 is kind of a hard thing to wrap your head around. So we try to kind of relate it back to, something a little bit more tangible. Next slide. Oh, just a finished project picture there. Next slide, please. And then this is just a quote from Carol Ross Barney about, the ability to incorporate this into their flagship project that they were working on McDonald's with. And it really delivered, what all the stakeholders were hoping to achieve, which was a lower carbon project that didn't affect budget or schedule. Next slide, please. And then this particular project, one of my favorites, to date, I believe is still the tallest high rise that it basically incorporated carbon capture into every single yard of concrete that went into it. So 47 stories at 300 North Michigan, close to 2,000 tons of embodied CO2 saved. So again, able to do all sorts of applications from the footings, the columns, to the core walls, to the PT decks, while still not affecting the schedule of the project and really delivering a really nice low carbon alternative for the owner. Next slide. Just a little bit picture of the construction there as it's going up. Next slide. And then again, as we'll get into the EPDs in a little bit here, but you break down an EPD into the raw ingredients, right? A1, all the materials that are used. A2 is the transportation, right? How do I get those materials to my facility to make my yard of concrete? Next slide. And then obviously A3 is the manufacturing of that material, through our plant and in the trucks and whatnot before it leaves our gate. So we really try to understand the logistics and the operations of how all of that works. And we have multiple locations that are on the river and or on rail. And, as you'll see in a picture here, we're moving 1,500 tons in each one of those barges. So we're able to really move a lot of material very efficiently up the river and have a much lower embodied carbon footprint for that particular material as it's a component for our final product. Next slide. And this is probably one of my favorite slides. It was quite astonishing to me once we did all these calculations to really understand how much better it was. And as you know, in downtown Chicago, we've got enough traffic issues as they are. So the more trucks we can take off the road, the better off. So an 8-tow barge equivalent to 464 semis. I mean, it's pretty astonishing. And again, optimizing via rail as well. Can we move more material via rail to different locations? And how does that ultimately affect the global warming potential? And even looking at moving more materials even further, via rail gives us an opportunity for some of these new emerging technologies that are coming out. Can we take a product manufactured here in Chicago and ship it to California without having a big impact, right? So those are the kind of the things that you really got to start to kind of get into the weeds on to ultimately continue to drive that carbon footprint down. Next slide, please. But, one of the logistical and operational challenges is when you move that quantity of material, where do you put it, right? Obviously it's beneficial from a carbon standpoint, but you also have to then have the infrastructure to hold it. So there's a picture of a terminal where you've got a cement dome that holds roughly 60,000 tons of any cementitious powder you need, and some other repurposed silos there in the middle, those pack of 3 there for storage materials. And then again, you see the rail cars there as well, being able to load rail cars and ship them out. So ultimately just maximizing the lowest carbon footprint modes of transportation that we possibly can, because again, it all adds up to that same final number on your EPD. Next slide, please. And then, as I mentioned, fuels, right? What are we using, right? Diesel, is obviously the pretty standard fuel, but, we starting to understand how does that impact the carbon footprint. And next slide. And, ultimately we've made a transition to a portion of our fleet where we're going to be using, it started out as CNG, just compressed natural gas, which obviously has a lower footprint, but then capturing CO2 or what I would call renewable natural gas, RNG from landfills, from dairy digesters, and putting that in as the fuel source. Has a much lower carbon intensity. And again, it does play a little bit into our EPD, as the trucks are used to mix the materials before they leave a gate. But I think as, when you start to consider the whole LCA of a project, looking at, how did that concrete go from my plant to the job site and what fuels were used? And, that factors more, like I said, into the LCA, the overall, reduction of the project as a whole. So it's, looking a little bit further down the food chain when it comes to the life cycle. But again, just all these things that need to be considered as we're evolving. Next slide. And here's just some carbon intensity scores, as I mentioned, of the different fuels. Obviously, you've got gas and diesel on the far left, have the highest, and as you go down to hydrogen, EVs, landfill RNG, and then, ultimately RNG coming from manure has a negative carbon intensity score. So, as this continues to evolve and the models and systems become more complex that can account for that, I think you'll start to see a lot more investments into capturing the CO2 from those digesters and putting it back into the pipeline so that they can be used as a fuel source. Next slide, please. And then environmental product declarations, right? I mean, how do we can't reduce what we can't measure. So, as Don mentioned, our industry's done a really good job of kind of jumping on this bandwagon and going out and getting EPDs done for our plants, for each plant and for each mix, right? So every time there's a project, if it requires a new mix, a new design, we can account for it. And we also, understand that, while when it first started, it was quite the undertaking. I mean, it's a lot of information gathering, but once that's done, it's quite an easy process to continue to maintain, and also enables us to look at these new materials, right? If somebody's got a new natural pozzolan or a new technology or a new way to make cement, if I know what that carbon footprint is, I can factor that into the system and understand really what is that reduction going to give me. And again, looking at economics as well, you've got to weigh that carbon reduction versus the cost, because there's a lot of these new things are emerging. You're just the economies of scale aren't there yet. So really trying to understand how that also affects, the construction process and the pricing of everything, because again, everybody's very sensitive to that. Next slide. And here's a snapshot of the NRMCA industry average EPD. So NRMCA surveyed their members, which I'm sure Don will talk about, so I don't want to steal his thunder, but they ultimately were able to put together, as a starting point for all of this. We're looking at different classes of mixes for strength, and then the amount of replacement, whether it was fly ash or slag, over various categories. So, again, the main number, everybody's really been focusing on is the GWP, the global warming potential, the kilograms of CO2 equivalent per yard or cubic meter. Next slide, please. It must have, oh, there it is. So again, here's a picture of an EPD that we've generated. And again, it allows us to kind of really take a look at what impact are we doing when we're putting these new mixes together or evaluating new technologies. And we're able to benchmark against, the NRMCA numbers and understand where does it fall. And again, each plant, each mix is going to be different. And, just it's all based on regionality, right? As I mentioned, how do we get the materials there? How far away are they from the source? All factor into that. So this enables us to really have that overarching view of, essentially a food label for our concrete as it pertains to the environmental impacts. Next slide. So yeah, that sums up my presentation. I would again appreciate the opportunity to talk about some of the things that we're working on, and would be happy to answer questions, I think, when Don is wrapped up.
Great, thank you, Ryan. We'll move into my portion of the presentation. What I'm going to talk about is just elaborate a little bit on the commitment that our industry has made in addressing the embodied carbon reduction scenarios that we can offer for our products. Our journey to carbon neutrality started back in 2009. At that time, the industry committed to a plan to reduce the global warming potential of its mixes by 30% by 2030. In 2012, we became an adopter of the Architecture 2030 Challenge, which raised the stakes for our industry to look at reducing our carbon footprint to a 50% reduction by 2030, and then achieve carbon neutrality by 2050. In 2014, as part of that process, we established the industry-wide EPD program that Ryan mentioned, a program where we surveyed members all over the United States, members and non-members actually, to create a database that benchmarked average mix designs to create a starting point to quantify where we were as an industry in terms of the global warming potential for average mixes across the entire country. In 2016, we established the Build with Strength program, which in part was developed to provide educational resources to start raising awareness about the effort our industry was making, and to demonstrate strategies and ways in which you could look to lower the embodied carbon footprint of ready-mix concrete. In 2011, we had achieved a 21% reduction in carbon footprint. And so we were pleased to see that our efforts to that point were leading to the ability to achieve the reduction impacts that we were hoping to. In 2023, we introduced our carbon calculator tool, which I'll talk about in more detail in a moment, which really provides a internet-based tool that very robust tool that gives you the ability to start comparing proposed mixes for various projects to the benchmarks that we've established as an industry. So fast forward to the Inflation Reduction Act and some of the things that that legislation is trying to do from the standpoint of sustainability, looking at trying to improve the carbon footprint of the procurement of building materials in the construction industry, funding for further development of environmental product declarations for various types of building materials, and also a labeling program, a program that would, similar to what we've seen over the years with Energy Star, but creating a label that would be easily understood, that would be a quick way that you could look at a given building material and identify its global warming potential, its degree of sustainability. So all of those are features that the Inflation Reduction Act was looking to support going forward. As part of that, in 2024, this year, NRMCA was selected for a grant of over $9.6 million. Public announcement was made in mid-July, with funding anticipated to start later in this quarter. In total, about $160 million in grants were selected, of which about $42 million are focused on concrete and constituent ingredients. And the funding for these grants is available over a 5-year time frame. So with the grant funding, our industry is anticipating that we will be able to move up our carbon reduction goals to achieve carbon neutrality by 2045. So reducing the time frame by 5 years. So in addition to that, we have 5 major objectives that we're looking at supporting with the funding that's been made available through the grant. If you're interested in learning more specifics about the grant, you can go to that website that you see at the bottom of this slide at our website, nrmca.org/EPA grant. So objective one is to look at increasing the number of ready-mix concrete EPDs. As I mentioned in the introduction, as Ryan described as well, a big part of what our industry is engaged in is raising the number of EPDs to cover the bulk of the different ready-mix combinations that are available through our industry. So we, as accurately as possible, support carbon reductions for various projects. A big part of that, the cost of developing EPDs, let's say 12 years ago, when the effort to do this was first introduced, it was cost prohibitive. It was well over $30,000 per EPD to generate the specific information. And in the case of our industry, that would cover one mix at one plant. And fortunately, those costs with the advent of computer technology and software, those costs have come down dramatically, about 1/10 of what they were before. But for many of our ready-mix producers that are, that are smaller operations, it's still a costly process to start looking at a variety of different mix designs that can be offered by a given plant. So the goal of objective one is to help to support the creation of EPDs and provide funding to help to reduce those costs. So as an industry, we can just further improve the large number of EPDs that are available to document sustainability performance of our industry. Objective two is to look at ensuring technical proficiency to help concrete industry personnel understand the significance of EPDs, what they can provide in terms of the information relevant to sustainability strategies on projects. So the goal is to certify 500 individuals within our industry to be better equipped to talk about the EPD impacts in our industry, and also to further, through the Build with Strength program, further the educational effort that we're making to help define the value of these tools for various designers. Object three is to look at concrete design tools to enhance low carbon mixes. One of the big efforts that we have made for a number of years is to encourage the move, when you're talking about ready-mix concrete specifications, to move from prescriptive-based specifications to more of a performance-based specification. Under the prescriptive method, you're basically identifying the recipe for the mix design, which leaves the typical producer with a little flexibility in terms of being able to offer alternatives or to otherwise optimize those mixes to improve them from a sustainability and performance standpoint. By moving more to a performance-based specification, you're now putting greater reliance on the expertise that industry players like an Ozinga can have in terms of really helping you understand, for the given location where you're trying to design and build a project, what are the capabilities of the industry and how can ready-mix concrete help and aid in reducing the overall carbon budgets of your project as much as possible. Another aspect of these tools is the carbon calculator, which helps to compare proposed mixes to baseline, and other educational tools that we've developed just to fill out the full context of how what concrete's role is in these sustainability strategies. Object 4 is to improve the benchmark database that we established. The database was originally created and is currently available based on 8 separate regions and national averages. And so by the end of 2024, we will be updating our benchmarks to 30 different regions across the country, including some benchmarks that would cover individual urban locations where we have enough participation to be able to provide that information. So overall, we're going to be moving to more and more localized information to just better inform projects at specific locations. And then through the funding of the grant, we're going to further refine the benchmark databases to include 50 separate regions by 2029. Objective 5 is to improve PCRs and EPDs, both for ready-mix concrete and also for constituent ingredients. So for example, developing product category rules, benchmarks, and environmental product declarations for admixtures, for aggregates, develop benchmarks for pavements, and then in general to harmonize the product category rules for concrete and various related constituent materials used in ready-mix concrete for greater accuracy and consistency. So now let's turn our attention to the NRMCA Concrete Carbon Calculator. It's a tool, as I mentioned, that came out last year. And so here we have an example of a multi-story, multi-family project. And for this hypothetical project in the Boston area, we have 6 different mix designs that are going into the overall design for the project. So in this case, we're looking at shear walls, columns, 2 different mixes for floors being constructed for the project, and then a mix design for basement walls and a separate mix design for the mat foundation. So the calculator is available. You can take a photo of that slide. You see that QR code that'll take you to the site, or you can access the site. The site address is across the bottom of the slide. The first time that you access this calculator online, you will be asked to input your email address and create a password. What that does is it creates an account that you can then access, and you're able to store the different projects that you analyze using the tool. So it's a nice feature in terms of being able to go back, look at past projects, replicate or make use of the work that you've done in the past on past projects using the tool. And so then there are a variety of screens that identify project information, as well as basic settings. You can use imperial or metric units of measure. The program will look for project area, the overall floor or floor area of the project, as well as whether or not you want to use carbon data. I won't go into a lot of data or detail about carbonation, but one of the things that's been discovered is the ability of hardened concrete, once it's put in place, to start absorbing CO2 from the environment, the atmosphere around the hardened concrete put in place. A lot of variables that affect the ability of the concrete to absorb the CO2, but it's just as Ryan described, it's the limestone components of the ready-mix concrete naturally, and this is a very simplistic description, but trying to revert back to its natural limestone stage And it's a mineralization. It's a permanent removal of the CO2 from the environment. If you go out to our website, you can find a lot of additional information and detail about carbonation. The MIT Concrete Sustainability Hub estimates that the quantity of carbonation from ready-mix concrete in place is about 14% recovery of the CO2 generated during that calcining process that Ryan described when the CO2 is released during the manufacturing of Portland cement. So the program actually has the capability of allowing you to account for the recovery of some of that CO2 based on a number of factors that the program includes. And then you look at the sourcing of information that you'll use to compare your benchmarks to the proposed mixes that you're working with. And we have the full complement of the NRMCA benchmarks, currently version 3.2, that covers national benchmarks as well as the 8 regions that I described. We also have information for the General Services Administration, the City of Portland has benchmarks for ready-mix concrete, as well as the Carbon Leadership Forum. We're also in the process of including benchmarks that have been developed for the Cal Green program, and we'll have those up and running probably early in 2025. And we'll continually be looking for additional sources of benchmarking information that we can add to this program. So basically, in this case, you see the table has been filled out with the 6 different applications that I described for our hypothetical project. And so you're basically identifying information for each of those mixes, including the total quantity of material for each application, and then identify the proposed global warming potential. Now, if you have EPDs for the various mixes that you're looking at including on the project, you will have that estimated GWP for each of the mixes, and you can just add that information here to this table. Or you're able to, if you have mixed designs, but the mixed designs don't have EPDs, you're able to enter the constituent ingredients separately as line items, and the program will approximate the global warming potential based on looking at the averages for those benchmark mixes that have been established as the basis for this program. So you have flexibility in terms of the information that you have that you can enter to create a carbon budget for the ready mix for your project. Once you finalize the entry of all that information, the program will then calculate a comparison between the baseline that you've selected. So in the case of Boston, we would use the Northeast regional benchmarks to make this calculation. And so the program then compares the baseline to the proposed mix design to identify a total overall GWP for each of the applications, a percentage for each of the applications, difference from baseline, as well as a carbonation factor if you're looking to see if there's some potential savings based on the specifics of each of the applications that you're comparing, and then it'll total up to provide you with an overall proposed GWP for your project. So it's a great way that you can take a look at the mixes that you're going to be using for your project, and then identify a budget for the ready mix concrete that you're using on your project, as well as the percentage of savings compared to benchmark mix designs, which can then be added to your ready mix concrete spec to identify the overall carbon budget for ready-mix concrete on your project. And so that's our carbon calculator tool. Our Build with Strength program has our Concrete Design Center, which is a free consulting service that offers structural system cost and performance comparisons. So let's say you're looking at a multifamily project, 3 to 7 stories with wood frame and 1 story of concrete. We can provide you with information in terms of how to optimize the use of concrete for that entire structure, provide you with first cost estimates between the wood frame and the concrete example. We typically see first cost being very competitive compared to what might be assumed when there's a lack of complete information that we have as an industry. So we've been able to convert over 400 projects nationwide on the basis of being able to provide more complete and accurate first costing information to demonstrate that concrete really isn't, in many cases, slight increase in cost, or it can even save money from a first cost perspective. And then we can also look from a performance perspective. We have a lot of good, useful information from the many projects we've converted to help provide information from an ownership perspective in terms of additional savings over the full life of the project that's possible for the owner to realize by moving from competitive products to concrete. A big part of what we do now is looking at specification review. Again, helping to demonstrate how to move from a prescriptive ready-mix concrete spec to a performance spec to improve the overall sustainability of your project. And then finally, with the use of our carbon calculator tool, we can help you take a look at that carbon accounting to establish carbon budgets for the ready mix in your project. So from the standpoint of specification review, looking at a variety of factors that can be adjusted, looking at documenting the full complement of ASTM standards or any standards governing the use of various constituent ingredients for ready-mix concrete. So you're able to allow for a fuller kit of parts, so to speak, for the ready-mix producer to avail themselves of in terms of optimizing the mix designs that you're requesting for your project. And we can also help to look at inclusion of various sustainability strategies and help identify ways to meet LEED requirements, for example, if your project is seeking those kinds of approvals. So our Concrete Design Center, I'm based in the Midwest. I cover 8 states. I'm based in the Chicago area. And I can certainly be of assistance for any projects in the Midwest, but I have counterparts in different parts of the country. And so if you get in touch with me, I can put you in touch with expertise anywhere you might be contemplating a project within the 50 states. We also have a codes and standards department that can look at specifics related to our benchmark mix and EPD offerings, as well as more general sustainability questions, fire codes, general building codes, as well as energy codes and standards. And so with that, I think Ryan and I will be glad to take any questions.
Thanks, Don. Maybe I'll just read a couple of questions that are in the chat right now. So one of the first questions was, how did the new SCMs impact cure time?
That's a great question. It really varies, to be honest with you. Some of them, depending on the quality of the materials or the reactivity, if you will, you could have little impact on set time, but it also depends on the amount of replacement, right? The higher you go in replacement, the less Portland or clinker you have in there. So that's going to probably extend the cure time as well. So, ultimately the idea is to try to figure out how do we incorporate these newer materials into our concrete without impacting the set or cure time. But in reality, it's not always going to be that simple. We do the best we can, whether you're trying to reduce the water cement ratio and increase admixtures, but then you could potentially have workability or pumpability problems. So really it's kind of a fine line, and understanding what materials you're using to, and what's the threshold in which, is acceptable for the, the practitioners actually installing it. So yeah, I wish I had a more solid answer for you, but it kind
Right.
of depends.
I would just add to that it seems like in the design, there should be an attempt to like strategize where you can allow for like greater amount of cure time. Perhaps like in your foundations,
Right.
that could be like a focus point where you can extend it, but maybe in the rest of the building as you're going up, you have to have different types of mixes that have shorter periods of time to not have an impact on the project schedule.
No, you're 100% right, David. I mean, that's how we look at the, like the tool Don just showed, the carbon budget, right? Can I achieve an overall carbon reduction for a building if I can maximize it in the footings, foundations, or say caissons where it's not as critical path, and then stick with something more traditional to stay on schedule. Was kind of like where we like to start. Eventually we'd like to use a low carbon mix in every application, but
Right,
we'll get there eventually.
right. The next question
Can
in
I,
the
can
chat.
I
Oh,
just, David,
go ahead,
can I
Don. Sure.
just to mention, I think, um, you listen to Ryan's response and it really points up that, every mix design is unique. And
Hmm.
so there are a lot of complexities involved in these issues. And it's just one more way to reinforce this idea that by moving to a more performance-based specification and relying more on the expertise that producers like Osinga can provide and bring them in as early as possible
Right.
to encourage the discussion and the strategizing so that you get the best mix designs and the best overall budgets for your project that's possible. To try and somehow predict that in your specification, things have just gotten so complex now because of these sustainability issues that it's really important to put your trust
Mm.
with the local ready mix producer.
Yeah, I definitely agree. The next question was, how does the addition of CO2 affect the ductility of the concrete? Maybe not a Chicago issue, but in higher seismic zones could be a concern. So, Ryan, I don't know if that's for you to answer.
Yeah, probably. Again, I haven't seen any effect on, the ductility, flexural strength, or, the modulus, if you will. So, really the only thing that we have ever seen change with the introduction of the CO2 is just the increase in strength due to the nano-sized limestone particles. So, again, a little bit better resistivity, I think, because of the nano-size, a little bit better particle packing. But other than that, I haven't seen anything that would be of concern in the ductility range.
Great, great. Next question is, what needs to happen on the regulatory front to mandate low to no carbon concrete? That's the question I always think about myself. So maybe Don, you have a good answer for this one. What do you see in changing in codes?
I think that what's important to consider is the context. The reality of ready mix concrete as a material, we use so much more ready mix concrete than any other material in the world for construction. And I mention all that because there's a tendency to look at, you see the percentage number of 8% of GWP in the world on an annualized basis is due to the production of Portland cement. Well, the reason why that number is so outsized has to do with the amount, the quantities of Portland cement being produced, because the material and the concrete produced from that Portland cement is so highly valued in the construction industry. we definitely need to move towards, in our industry, as you've seen today, or I'm hoping you've seen today, is moving towards more carbon neutral approaches. I'm not sure regulation is going to help us get there, because I think up till now, our industry has largely done it on its own. There are programs, Minnesota as one example, Buy Clean legislation, other states doing the same, that are mandating lower embodied carbon budgets for all types of building materials.
All over, right.
Yeah. So, I mean, there are regs coming on board that are governing publicly funded projects. But again, I think, concrete by itself is not going to solve the problem. If anything, concrete offers more, I see concrete offering greater solutions because of the flexibility and the ability to lower the amount on a percentage basis for our products relative to other materials. I'll tell a quick story. In Minnesota, one of our producers was involved in a project where they were offering 40% reduction for the ready mix materials used in a given project that was trying to achieve certain sustainability budgets. The design team came back to that producer after about 3 months and we're very pleased with the 40% reduction, but we're having trouble achieving reductions for other materials they had anticipated using in the project. They asked for an additional 10% reduction in the Portland or the ready mix concrete on those for that project, so that they'd be able to maintain their budgets, because other materials weren't delivering the same level of reduction that the ready mix concrete could achieve. We represent a solution because of the quantity of material being used and the potential for reduction.
Thanks, Don. I think that's kind of it for questions. I would just say, just some ending thoughts of my own. Don, is like, I'm very impressed by the proactive nature of NRMCA to reduce carbon in cement and concrete. It's really what needs to happen, hope to happen, across the entire building materials industry. And also just impressed by the availability of NRMCA to assist architects and engineers in getting to the right sustainable strategy for their mixes.
Great, thank you.
So thank you, Brian. Thanks, Don. Somebody had a question about the recording, and there will be, this is being recorded and will be available on the AIA Chicago website probably within the next week or so. So look for it. And any other questions though for AIA about this event, please let us know. Thank you so much.
Thanks, everyone.
Thank you.
Bye-bye.